Okay, so in this lesson, we're going to be looking at reviewing for your test. And so there are several questions that we have here that range from knowledge, application, and I think there's one thinking question in this as well. So for the warm-up, it says, given y equals f of x, describe in words the transformations that occur to the graph of y equals 3, f of 2x plus 6 minus 4. So if I actually look at the way the equation is written, I'll notice that the horizontal transformations are not in the factored form that they need to be. So the first thing I'll do is factor out the 2 where the horizontal transformations are concerned. Okay, and so when I factor out the 2, I'm left with x plus 3. And so now I can look at each of the different transformations and describe them. So the first transformation I see is a vertical stretch by a factor of 3. Then a horizontal compression by a factor of a half, a horizontal shift to the left, 3, and then a vertical shift down, 4. So I'm just going to write that down quickly. So we have a vertical stretch by a factor of 3, a horizontal compression by a factor of a half, and a horizontal shift to the left, 3, and finally a vertical shift down 4 units. Okay, or down 4. Okay, and so the first example we're going to be looking at from the practice questions is a question where we're actually going to transform an exponential functions, and the transformations that are going to be applied to that exponential function is a vertical stretch by a factor of 3, a horizontal compression by a factor of a half, a horizontal shift to the left 3, and a vertical shift down 4. So let's take a look at that example. So here's example 1. It asks us to graph the following exponential function. And so if you remember back from, I believe, lesson 4 where we looked at how to graph exponential functions, remember that the first thing we looked at is what the base function is, and then we worked with it from there. Now, before I even look at the base function, and I guess maybe we can look at the base function first, it's not a big deal. The base function in this case, if I look at the actual function that's given, what I'm looking for is where the exponent is and what the base is that this exponent is being applied to. And I can see that the base where the exponent is being applied to is a base of 2. So I know the base function is going to be y equals 2 to the exponent x. And all the other numbers in this equation are all different transformations that are being applied to the base function, y equals 2 to the exponent x. Okay? So the 3, the 2 in the exponent, the 6 in the exponent, and the minus 4 at the end are all different transformations that are being applied to the graph of y equals 2 to the exponent x. Okay, we can also say what the horizontal asymptote is. And the horizontal asymptote depends on how the graph has been shifted up and down. So I can see that there's a vertical shift down 4 units, so that tells me right away that the horizontal asymptote goes from being 0 down to being negative 4. Okay, so there's the key piece of information I need so far. We also need a set of key points, but we'll come back to that in a second. If we take a look at the function that's given, notice that the horizontal transformations, which will always appear in the exponent part, have not been written in factored form. So the first thing I need to do is actually factor it out. So I'm going to have 2 to the exponent 2 bracket x plus 3. And then minus 4. So there's the equation in factored form. That's the way I need to see it. And you'll notice that the 4 different transformations that we have here are the same as the ones that we just saw in the warm-up. We have a vertical stretch by a factor of 3, which we just saw. We have a horizontal compression by a factor of a half, which we just saw. We have a horizontal shift to the left, 3, and a vertical shift down 4. So the equation that we had in the warm-up was for a general function, any function. And so we're specifically looking at those particular transformations that are being applied to an exponential function. And the base of the exponential function in this case happens to be y equals 2 to the exponent x.